Good morning. This is Dr. Wells. We're going to go through my notes on induction. I'll probably take several different videos to do that, so you can obviously break at any time you want to. The material that I'm going to be talking about here is most of it will form the basis for the quiz questions. So when you take the quiz, actually there's two quizzes. When you take the quizzes, make sure you've got that material, studied, and of course, you can use your notes as you take the quiz. Make sure that you remember that you only have one try on the quiz. Okay, the first thing that I want to talk about is an induction compared to deduction. You've studied deduction and you've taken a quiz, or should have a quiz done by today. And deductive arguments are one where the conclusion is certain, or in other words, it has to follow exactly from the premises. There's no doubt about it. Inductive arguments are different. They are not certain. You can reach a conclusion that is more likely than not. One way of thinking about it is it's like a bet. You take a bet on a football game or a baseball game, something like that, and you think it's more likely that it'll come out the way you predict than not. So you take the facts that you know about and combine those into the form of a premise, and then the conclusion would be your prediction. The 49ers are going to win. The Warriors are going to win. That would be the conclusion of an inductive argument, where the premise would be what you know about those teams. Maybe they've got great players, bad players, whatnot, and those are facts or reasons that will lead you to the conclusion. So that's an inductive argument. It's not certain. You might predict the Warriors are going to win and they lose. You might predict that the 49ers are going to win and they lose. And so those are inductive arguments, or that's the way an inductive argument works. And it's the conclusion is hopefully has a better chance of being right than wrong. Just like when you place a bet, you hope that the bet's going to come out the way you want it to. And so a good inductive argument is one where you have good evidence to support the conclusion. Again, it's still not certain, but it's likely that you're going to be right. And so that the strong evidence or good evidence leads to a strong argument, and bad evidence leads to a weak argument. So inductive arguments are strong or weak. They are not certain. Excuse me. If you can remember what I just spoke about, you'll be well on your way to learning this material. So let's talk about weak and strong inductive arguments. So let's say that Evergreen hires a new philosophy instructor, but you've never seen him or her, and so you don't know the gender of the new hired philosophy instructor. So you do some research and you find out that 90% of the people who teach philosophy are male. Okay, so that becomes your evidence or your premise. And so you have not seen the instructor's name is Dr. Nguyen. So you're going to place a bet. Your bet is that based on the fact that 90% are men, that Dr. Nguyen will turn out to be male or a man himself. And so that's an example of an inductive argument where you're you're not certain that Dr. Nguyen is man, but you think there's a pretty good likelihood that he is. And so that's what we would consider to be a strong argument. However, it is still possible that he will be, that Dr. Nguyen will be female. It's not impossible. So if we look at an example of this argument, you can find this on the first page of your notes, and you'll see first premise is most X's are Y's. That would be like most philosophy instructors are men. And then you would say this is an X, which would mean this is a philosophy instructor. And so the conclusion would be, therefore, this is a Y, which means that the philosophy instructor is a man. So this is an argument of what we call going from the general. In this case, the general is the totality of philosophy instructors to a specific. Okay, so the general would be like most philosophy instructors are male, and the specific would be like Dr. Nguyen. Okay, there's a second type of inductive argument. The first one was going from general to specific. This one is the reverse. It's going from specific to general. And this, at first look, doesn't seem like it makes much sense. How can you go from specific, a particular situation to a general situation? In other words, wouldn't that be like hasty generalization? If I see two Vietnamese students stopping at a gas station, and I say, okay, well, there's two Vietnamese students, so and they're students at EVC, so I'm going to conclude that all the students at EVC are Vietnamese. Okay, and that's what we would call jumping to a conclusion or making a hasty generalization. It's taking a little bit of facts and generalizing them. However, there is a way that we can make a reasonable argument going from specific to general. And the way we do that is to make the specific like a miniaturized version of the general. So let's imagine that we have a doll's house. It's like a miniature house, and that this house is exactly the same, a perfect model of a real house, full-size house. Okay, and so the general idea is what we see, what exists on the dollhouse will also exist on the real full-size house. So the idea that, in effect, we're perfectly modeling the real full-size house, and we can do some research on the model house, and whatever we discover will also work in exactly the same way on the full-size house. Okay, so to continue with our little analogy, the model house is the specific, and the real house, the full-size house, is the general. And so because we've made the model house just like the full-size house, except it's a smaller version, then the things we find out about the model house will turn out to be the same on the big house. So the model house would be the sample or the selection, and the full-size house would be the general. So to make this work, we have to make the model house exactly like a completely exact 100% replica of the big house. So if we, let's say, if we want to determine how many, what percentage of teachers are Democrats, then that's a big group. That's like, there's quite a few teachers, a couple million, and of course we don't know what percentage of them might be Democrats. So we take a sample or we build a model. We take our sample is exactly like the target or the general in every way possible. If the average age of a teacher is 43, then we make the average age of the sample of teachers 43. If there are more female teachers than male, then we make our sample have more females than males at exactly the same proportion. If some teachers are richer than others, we take that same proportion and apply it to the sample. If some are quite well off, maybe 10%, then we make our sample the same. And so we go on and on and on and take all the things that we can determine and make the sample exactly a model version of the full target. The target is like the full-size house. In this case, the target would be all the teachers. And so if we've made a really good model, just like a really good model boat, and it's exactly the way the full-size, model house, and it's just the same as a full-size house in every respect except smaller, then we can take this sample and we can say, okay, we're going to ask all the members of this sample, and let's say we have 1,000 people in this sample. And remember that this sample is made to be representative. It's an exact duplicate of the large group, the target, in every respect. So we ask the teachers in the sample, are you a Democrat or a Republican? And so we get a result. The result is that 55% maintain that they are Democrats. And the remainder are either Republicans or independents or some other type of political belief. So then what we do is we say, based on that evidence, is we then predict that the results of a full poll of all teachers would turn out that 55% are Democrats, because the model or the sample is exactly the same as the full size, the target.